Algebra 2, Target 8. I can solve a quadratic equation. Today's focus is continuing to use the quadratic formula. This time we're going to introduce some imaginary solutions, and we're going to determine the number and type of solution with the discriminant. Meaning we're not going to go all the way through and find a solution. We're just going to see how many are there, what type are they. And then the discriminant, that's that magic word for what's underneath our square root. I alluded to it yesterday. Today we're going to talk about it and decide how many roots there are using the discriminant. All right. So first off, our discriminant is the value underneath the square root. Basically, b squared minus 4ac. We can use our discriminant to determine the equation's number of solutions and the type of solutions. First off, because it's a quadratic, there's always two solutions, but they're not always going to be real solutions. All right? All right? So, using the discriminant, we can see there's three possibilities. It can either be positive, it can be negative, or it can be zero. All right? If it's positive, you're going to work through the problem as normal. You're going to do your plus, you're going to do your minus. You're going to get two solutions. We say two real solutions. Right? The other option that we talked about yesterday was it was zero. You work through it, you got the discriminant 0, your plus or minus 0. Well, you can't add or subtract 0. You're going to get one real solution. Now, I said there's always two solutions. This is considered a double solution. Okay, it's one solution, but really it kind of happens twice. So you're going to have two real solutions, one real solution, which counts as a double, or two imaginary solutions. That's when your discriminant's negative, and you get the square root of, like, say, negative 50. Well, you got that I in there. Right? And so you'll have two imaginary solutions. All right, so let's look at some examples here. Right? So this first example, we got negative x squared plus 4x equals 50. We need to get it in a standard form like all times for quadratics. You got two choices. You can move everything to the left or move everything to the right. In this case, I'm going to move everything to the right. I kind of like, and it's just a matter of preference for me, I kind of like my a to be positive. So I'm going to add x squared, subtract 4x. I got 0 equals x squared minus 4x plus 5. We got my quadratic. The more times you write it out, the easier it is for you to remember it. So just a little hint if you're having problems remembering it. Write it out as many times as you can. Check it after each one until you're getting it. Right? Plug and chug. B is negative 4, so negative b would be 4. B squared would be negative 4 times negative 4, which is 16. Minus 4 times a, which is 1, times c, which is 5. All over 2 times a, which is 2 times 1, which is 2. All right, we'll clean this up. We'll do the discriminant first. 16 minus 20. 16 minus 20 is negative 4 over 2. Now here's where we're going to the complex realm because of that negative. Okay, we're just going to break negative 4 into 4 times negative 1. Square root over each one of those. So what we got is 4 plus or minus 2i over 2, and then we'll break it into two fractions. 4 over 2 is 2, plus or minus 2 over 2 is 1. So our solutions are 2 plus or minus I. So when you break it and you list it, if you do it separately, 2 plus I, 2 minus I. Notice they're a conjugate pair. Okay, that's not a coincidence. Your complex numbers, your complex solutions will be conjugate pairs. All right? solve this one. Pause it, try it on your own. All right, first step, excuse me, first step, standard form. So you're going to move everything in this case to the right. Subtract 7x, add 5x squared, add 4, do that to both sides. Or not. There we go. Left side will be 0. Right side will be 5x squared minus 5x plus 7. We're going to use the quadratic formula. All right, plug and chug. B is negative 5, so negative b will be 5. Right? B squared will be negative 5 times negative 5, which is 25, minus 4 times a is 5. B is 7. All over twice a. A is 5, so twice a is 10. Do our discriminant first. We get negative 115. And if you can reduce the radical, that is best. But treat it as square root of 115 times the square root of 1, or negative 1. Negative 115, sorry, 115 doesn't simplify, so we got 5 plus or minus I square root of 115 over 10. All right, you can leave it like that, or you can split it into two fractions. And that should work as well. All right, now when doing these problems, pay careful attention to the question, all right? Find the discriminant and give the number and type of solutions. It does not say give the solutions, it just says tell how many they are. All right, I got 3 questions on this page. I'll do the first one to kind of model and then try them and see what you can get. All right, so first off, make sure it's in standard form it is, and then do the discriminant. B squared minus 4ac. B is 4, so that'd be 16 minus 4 times 2 times negative 4. Simplify that. 16, 4 times 2 is 8, times 2 is 32, a double negative. 16 plus 32 is 48, which is greater than 0, so we have 2 real solutions. 2 real solutions because our discriminant is positive. Try the other 2. I'll do them one at a time. Pause and wait. All right, so our discriminant, b squared minus 4ac. B is 12. 12 squared is 144. A is 3. C is 12. All right, 4 times 3 is 12. 12 times 12 is 144. So we got 144 minus 144, which is 0. So there's 1 real solution, which is a double solution. You do not need to say that. You just need to know that's a double solution. That distinguishes that it's at the vertex as opposed to off at different points of the parabola. The next one, get it in the standard form. We'll subtract 9x. We'll add 11. Substitute in. Okay, b is negative 9. B squared is 81 minus 4 times 8 times 11. 81 minus 4 times 8 times 11 is negative 271. Okay, that is less than 0. Because it is less than 0, we have 2 complex solutions. Here's 3 more. Try these 3. We'll go through them after you try them. All right, number 7. Standard form, so we'll subtract 5. All right, plug into our discriminant. We got 4 minus 4 times 7 times negative 5. Here we got a double negative, so it's going to be adding. So 4 plus 4 times 7 times 5. You don't need to be too much of a math whiz to see that's going to be positive. That's 144, which is greater than 0, positive. So there's two real solutions. Okay, number 8, standard form. So we'll have 4x squared plus 6x plus 9 equals 0. Plug that into our discriminant. 36, b squared is 6, minus 4 times 9. 36 minus 4 times 9 works out to negative 108. Negative 108 is less than 0, so we have two complex solutions. And finally, number 9. We're going to want to get it to standard form. So we're going to have negative 5x squared plus 10x minus 5 equals 0. Okay, we're going to do our discriminant. B is 10, so b squared is 100. Okay, A is 5, negative 5, sorry. B, or C, is negative 5. Right here we have a double negative, so two of them are going to cancel. We're going to have 100. 5 times 5, that's 25, times 4 is 100. That's 0. Our discriminant is 0, so we have one real solution, which is a double solution, meaning our solution lies on the vertex. All right? So in conclusion, you can have imaginary solutions or complex solutions when solving. That just means we're above or below the vertex of the axis. We don't cross the x-axis. And we can tell that quickly by using our discriminant, which is the part underneath the square root, b squared minus 4ac. If our discriminant is positive, there are two real solutions. If our discriminant is 0, there is one real solution, which counts as a double, meaning it's on the vertex. And if it's negative, there are two complex solutions, meaning there is a real and or imaginary component, or there is an imaginary and or real. Definitely has the imaginary, may or may not have the real.